Hello and welcome back to Moles Part 2, using moles to count atoms. Did you know that if you know how much a group of things weighs and how much one of those things weigh, you can use math to figure out how many there are without counting. Oh, that's amazing. And this is where, my kids are like, oh, miss, when are we ever going to use this in our real life? Well, let me tell you, children, I heard a story. I actually read it on the internet about a guy who was working at a mechanic shop, and it was time for them to do inventory. And in the past 10 years, before he worked there, they always counted all of the bolts and screws and nuts by hand, costing hours and hours and hours of their time. And this guy gets to work there, and he's like, well, if we just weighed them all and then weighed one, you could figure out how many they are. And the boss was like, oh, that's amazing. And I'm like, yeah, it is. That's what we're doing, okay? Also, if you ever are really, really rich and for some reason you just really want to like swim around in a thing of coins, you can weigh your coins and figure out how much money you have without having to go through and count every single coin. For instance, here's our first problem. I'm going to hand you 1,500 grams of pennies. You know that one penny weighs 2.5 grams. So instead of sitting there and counting every single penny that I hand you, we could say, well, if I have 1,500 grams of pennies and I divide that by 2.5, which is how much one penny weighs, that equals 600, which means I have 600 pennies. Wow, that was a lot faster than having to count out all those pennies, Miss DeLuca. I know. It's amazing, right? Yes, thank you for teaching us such an important life skill. You're welcome. So, we know that 100 pennies is equal to $1. So if we have 600 pennies and we divide that by 100, we know that that is $6. Whoa, that's amazing, Miss DeLuca. I know. So we have 600 pennies, which is equal to $6. Wow. So here, this graphic says Samsung pays Apple $1 billion fine by sending 42 trucks full of pennies. So if anybody can tell me in a comment on Google Classroom how much those pennies weighed, I'll give you a prize. So that was a truly elementary example, but I want you to see how easy it is if you take what you know about like pennies and math and apply that to atoms. You can do the exact same thing. It is not hard. It is not hard. It's the same thing. You're just using different numbers. Okay? So we count atoms this way because they are too small and too numerous to count by hand. So like how if you had 1 billion pennies, that'd be way too many pennies to just sit there and count. You would like spend the rest of your life counting pennies. We can count them by how much they weigh. All right. So the Cullinan diamond is the largest gem quality diamond ever found, weighing 621.35 grams. So how many moles, because remember a mole is just a number, so how many moles of carbon are in the Cullinan diamond and how many atoms of carbon are in the diamond? Okay, so obviously diamonds are just carbon that's been squished and lined up in straight rows. So what our problem is asking us is we want to know how many moles of carbon, and once we find out moles, we can figure out how many atoms. So we need to know the first thing, how much does 1 mole of carbon weigh? Well, we can go to the periodic table, and we know that 1 mole of carbon is equal to 12.01 grams. Okay? So, just like we did with the pennies, if we have 621.35 grams of carbon, and we divide that by what we know 1 mole of carbon weighs, that gives you how many moles there are, which is 51.74 moles. Okay, so in that 1 diamond, there's 51.74 moles of carbon. Okay, so this is a number, remember? So now, so how many moles? 51.74 moles. Okay. Now what else do we already know? We know that 1 mole of anything is equal to 6.02 times 10 to the 23rd. So in order to figure out how many atoms, we have 51.74 moles. This time, instead of dividing, we're going to be multiplying because we want to know how many atoms are in this. So times 6.02 times 10 to the 23rd. Oh, Mr. Luca, we don't remember how to do scientific notation. That's okay. We're going to get a refresher. So, this is scientific notation. All your numbers have to be in scientific notation. I'm going to move this decimal 1 place this way to make this 5.174 times 10, and I moved it 1 place, so this is 10 to the 1, times 6.02 times 10 to the 23rd. Okay. So now I'm going to multiply these 2 numbers together, which gives me 31.15, and then I'm going to add my exponents together, so times 10 to the 24th. Okay, that's an answer. That's not in correct scientific notation. So then I have to move this decimal 1 place, so make it 3.115, and then because I moved it, I need to add 1 decimal place to my exponent, so times 10 to the 25th. And this is atoms of carbon. Okay, so in 51.74 moles of carbon, there are 3.115 times 10 to the 25th atoms. So that's how many atoms there are. Now, if I took that out of scientific notation to give you a number that you're more comfortable with, that would be, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. This is how many atoms there are in that 1 diamond. I don't even know what to call that number. It's so big, okay? Like millions, billions, trillions. I don't even know what comes after that. So that many atoms. But that number is represented by this. They're the same thing. It's a number, not an equation, okay? So all you're doing today with your practice problems is you're going to tell me how many moles are in something or how many atoms or molecules are in something, okay? Don't worry if this is confusing. Just do your best, work together, try to figure it out. I promise it is not as hard as you're thinking it is right now, okay? Just try it. You are going to need to turn this worksheet in to me at the end of class, and then I promise we will go over it when I come back. Okay? So I'm going to start number 1 with you. You need to show your work, use significant figures, and do units. That's a lot of things that you have to do all at once, but you can do it. I believe in you. Okay? So how many grams are there in 5 moles of lead? Okay. So 1 mole of lead. I'm going to look on my periodic table like we did last time, and all I have to do is write down the average atomic mass of lead, which is 207.2 grams. Okay. So if I have 5 of those, then it would be 207.2 grams times 5, which is a number. Do you have a calculator on your phone? Sorry. Hold on 1 minute. All right, I got it. It's 1,036 grams. Okay. Do need to use significant figures. So here we have 5.00. So this is 5.00 actually. That's 3 significant figures. So I need to have my answer in 3 significant figures. This is 1, 2, 3, 4. That's too many, so I'm going to need to round. So 1,040 grams. Okay, that's how many grams there are in 5.00 moles of lead. Okay, so the rest of these problems are just figuring out that same thing. So then when you get down to problem number 6, it is going to take that step that you just did and you're going to add on to it. Okay, so you know how to find the mass of 1 mole. So now you can find the number of moles in a mass. It's just the opposite of what you just did. So how many moles of silver nitrate are there in 80 grams of silver nitrate? So first you need to know the chemical formula for silver nitrate, which is AgNO4. So figure out silver nitrate. Then you're going to need to figure out how much 1 mole of silver nitrate weighs. Okay, so how much does Ag weigh? How much does the nitrogen weigh? And then we've got 4 of the oxygens. So how much does that weigh? All right, so I go to my periodic table. I look for silver. Silver is 107.87 grams. Nitrogen is 14.00 grams. And oxygen is 16.00 grams. This one's times 1. This one's times 1. This one's times 4. Okay. Can you unlock it? Which is 107.87 plus 14 plus 16 plus 16 is 32 plus 32 is 64. Plus 64. And then when I add those together, 107.87, get 185.87 grams per mole. All right, so we figured out That is 1 mole of silver nitrate weighs 185.87 grams per mole. Okay, so if I have 80 grams, 80.00 grams, and I'm going to divide that by how much I know 1 gram weighs, or 1 mole, 0.87 grams per mole. Okay, then these cancel out, and I'm left with 80.00 divided by 185.7 is 0.4304 moles. Okay, and significant figures, there's 1, 2, 3, 4, 1, 2, 3, 4. That's my answer. Okay, so you're just, sometimes it might be bigger, sometimes it might be smaller. If you only have 80 grams, you definitely is going to be less than a mole, because 1 mole weighs 185.87 grams. Okay, so then you're going to do the rest of those problems that way. Okay, till you get to number 10, and that's all you have to do. Okay, once you are finished with this practice worksheet, you're going to turn this in. Then you're going to need the other piece of paper that says Micro Rocket Lab on here. This is a pre-lab. It is kind of long, so you can take this and work on it at home as well. But I am going to need you to turn it in. Otherwise, you're not going to be able to do this lab. So in this lab, we are going to be making rocket fuel exactly the way that they make rocket fuel for real spaceships. So we are going to be harvesting hydrogen gas and oxygen gas, mixing them together, igniting them, and flying our own rockets, albeit very small. So before I can let any of you do that, you are going to need to answer all of these questions, because we will be using a high concentration of hydrochloric acid, a higher concentration of hydrogen peroxide, which is very dangerous, and then some zinc. So I need you to go through. If you don't know the answers to these questions, obviously, because that's why I'm asking you to do it, go to Google and look it up. Okay, you're going to need to go to these. So there are these MSDS sheets for hydrochloric acid, for hydrogen peroxide, to make sure that you know what hazards there are, what you need to do to protect yourself, what you need to do in case of an emergency, and like if you swallow it, what do you need to do? If it gets in your eye, what do you need to do? Because I can't let anybody do this lab without completing this and turning it in. So if you want to fly rockets, you need to do this and turn it in. Okay? This is going to be due when I see you on Tuesday. So make sure you get this done. This worksheet is due at the end of class. So work on this worksheet first, turn this in. Once you get this done, work on this. And then you can take this home and work on it and bring it back on Tuesday. Yep, that's all. So have a great weekend, and I will see you next week.